Math 2414, arc length, video 2. Arc length example 1. Find the arc length of the square of y minus 1 is equal to 36x cubed on the interval 0 is less than or equal to x is less than or equal to 1 for y is greater than or equal to 1. This first example might make you do a double take and go, whoa, what just happened here? You told us this, and you didn't even give us a function. You gave us some messed up equation that has squared y's and cubed x's. Yeah, but number one, this doesn't say it's a function of x, but we can make it say a function of x if we solve for y first. And number two, I went ahead and gave you the graph. This graph isn't even a function because it violates the vertical line test. And it has what's called a cusp at 1 because there's a sharp corner, meaning that we're not differentiable with respect to y there. But look closely at the restrictions placed on x and y. We're being told to find the arc length for y is greater than or equal to 1. Here's where y is equal to 1, greater than or equal to is above that, so we can pretty much just ignore this, which now makes it a function. So what's that function? Well, let's solve for y. If we wanted to solve this for y, we would start by square rooting both sides. Now, technically speaking, when you square root both sides of an equation, you should put a plus minus. But let's simplify that first, and then we'll deal with the plus minus in a moment. The square root of 36 is just 6, so that's good. And then we would be left with the square root of x cubed. But we don't do calculus to radicals, we do calculus to powers. The square root of x cubed is a power, is x to the 3/2 power. Let's finish solving for y before we figure out what to do with the plus minus. If we add 1 to both sides, we get 1 plus or minus 6x to the 3/2 power. So this would be our function. Although I would be hard-pressed to call this a function as is, because the plus minus will give us two outputs for a single input. For example, if we put in 1 to the 3/2 power is 1, and then times 6 is 6, but then we have y equals 1 plus or minus 6, so we would get y equals 7 and y equals -5, and a function can't do that. But remember our restriction for the y's. Y has to be greater than or equal to 1. So we can choose the plus minus that will guarantee that. So which should we choose? Well, since our x's are not negative, x to the 3/2 power will be non-negative, so it'll be 0 or greater. So mostly it's positive. Times 6 is still positive. So it boils down to, do we want to do 1 minus a positive number or 1 plus a positive number? Well, if we're keeping the y's greater than or equal to 1, it has to be 1 plus. So our function is f of x equals 1 plus 6x to the 3/2. And don't get me wrong, some of your homework problems will start here, but some will not. That's how come I'm doing an equation that's not written in function notation first, but will be written in function notation eventually. All right, so we found our function. We know the interval over which we're integrating. That would be this one. So now all we have to do is set up and evaluate the integral. To set up the arc length integral, first we have to find the derivative. That's pretty easy. The derivative of 1 is 0, so it's gone. For the derivative of 6x to the 3/2, we would bring down the 3/2, leave the 6 alone, lower the 3/2 by 1 to make it 1/2. And 3/2 times 6 is 9, so we get 9x to the 1/2. And I can write that as a square root, but we don't do calculus with square roots now, do we? Our next move to set up the arc length integral is to square the derivative. So if we square the derivative, we square this. Well, 9 squared is 81. And if we square x to the 1/2, we would multiply the powers. 2 times 1/2 is 1. So the square of the derivative is just 81x. Therefore, let's write it up here. our arc length integral will be the integral over the interval of x values from 0 to 1, the square root of 1 plus this. And now we've turned it into a calculus 1 problem. So how do we integrate this? In a word, substitution. If we let u equal 1 plus a1x, then du will equal 81 dx. So to build our du package, we're going to have to multiply an 81 on the inside and balance it with its reciprocal on the outside. So we'll have 1 over 81, integral from 0 to 1, square root of 1 plus 81x, 81 dx. And honestly, I should have written that square root as a 1/2 power by now. So let's do that. All right, we're ready to make our u substitution, but since this is a definite integral, we should probably go ahead and change the limits of integration as well. For an upper limit of 1, x equals 1 will imply that u is equal to 1 plus 81 times 1. So the new upper limit will be 82. And make this u a little better. The lower limit, x equals 0, implies that u will equal 1 plus 81 times 0. Well, that's a little bit easier. That's just 1. So our arc length is going to be 1 over 81 integral from 1 to 82 of u to the 1/2, and then all this becomes du. All right, we're practically home free. The antiderivative of u to the 1/2 is 2/3 times u to the 3/2, but we had the 1 over 81 in front, and this is going from 1 to 82. Remember, we changed the limits of integration so we don't have to undo the substitution. 1 over 81 times 2/3 is 2 over 243. And then now we just have to evaluate u to the 3/2 at the upper and lower limits. 82 to the 3/2 minus 1 to the 3/2. Well, the 1 to the 3/2 is just 1, so there's not a whole lot to look at there. But what about the 82 to the 3/2? Technically speaking, there's nothing wrong with 82 to the 3/2. But as some people like to use technology to check their answers, and others like to use it to just flat out get their answers and try to backdoor their way into the work and stop doing that because I want to give zeros for people who try to do that and think that I don't know that they're doing it. But if you got something like 82 to the 3/2 power, it can be simplified. There's a standard way and there's also a slicker way. The slicker way is to think of the 3/2 as a mixed number. This is one of the rare times I advocate using mixed numbers in calculus. If you think of it as 82 to the 1.5 power, 1.5 literally means 1 plus 1/2, which means I can split this into 82 to the first times 82 to the 1/2. 82 to the first, of course, is 82, and then the square, 82 to the 1/2 is just the square root of 82. And that square root can't be simplified. You can try it, but it won't. So I can rewrite 82 to the 3/2 as 82 times the square root of 82. 1 to any power is 1. And I think that would be a good place to stop this answer. The only other thing you could really do is distribute the fraction, but I don't see any benefit to that. It's a messed up looking answer, but you're going to get those because you're integrating a square root, which is a 1/2 power, which invokes a 3/2 power, which creates messes. Half the battle is the setup. The other half is finishing the integral. And again, this one pretty straightforward because it was just a u substitution.